Hello everyone, so today we are solving this problem, make two arrays equal by reversing the subarrays. In this question what is given, that we are given two arrays, like one of them is called the target and other one is ARR. Okay, so basically what we have to do is we have to make uh, uh, these array equal, okay, by using the reversing of any subarray. Okay, for example, see here we have this array target and we have this another array. So if we do reverse, if we can achieve this thing, then we should return true, otherwise we should return false. Now I can say one statement here, that if we find the frequency of all the elements in one array to the other array, if both of them, the frequency of all the characters is equal, then it would return true. This would be always true, that we can make the swap of subarrays and we can equal the both arrays. Now you might have a question that how can I say this without any proof? So let me show the proof of it. So see here, I have taken, this is my ARR and this is my target array. Okay, now we can see that the frequency of all of them is same. Okay, 5 came one time, 7 came one time, 3 came two time, 2 came one time, 1 came one time. So now I have to prove whether this guy would be always lead to a solution. So we have to make such reversal, we have to pick the certain subarray and then we have to do reverse, and finally we have to make this target equal to ARR. Okay, so how we will do it? So see here, there are 3 and 5, right? So in target 3 and 5 should be here, right? So let's do one thing, we can choose this subarray first. Okay, and if we reverse it, this will become 3, right, and this will become 5, correct? So let me correct it. So after reversal, this will come here, 3 will come here and 5 will come here, correct? Now let's say we are doing one more reversal here for this subarray, right? So 3 will come here, this would become our 3 and our 1 will come in place of 3. Okay, so let me write it down. So this would be our 1. Okay, so till here fine everything. Now what we can do is, let's say we are doing a reversal between among this subarray. Okay, so in this subarray what will happen, 5 will come here, right? So 5 is coming here. Now in place of 5 it would be 7 here, so let me cut it down and put 7 here, and this will become our 2 and this would become our 1. Okay, now till here we are fine, 3 and 5 came to this place and this guy 2 is already its place, right? So 1 is also at right place. Now we have to do only the one reversal here. So when we do reverse it, 3 will come here and 7 will come here, right? So now you can check, first place 3, here also 3, this is 5, here also 5, this is 2, here also 2, 1 1 3 3 7 7. So now we can guaranteed say, because there is no boundation, we can do any number of times the reversal of the subarray. Okay, so we can guaranteed say that if the frequency of the elements is same in both the arrays, then there is definitely a solution by making the subarray reversal to equal both of the arrays. Okay, so now in this case what will happen, finally our problem has been changed. Now our problem has modified, that we have to only find one thing, that whether the frequencies are same or not. If there is a difference of frequencies, then we will return false, otherwise we would be returning true. Now there are two ways to do that. Okay, number one way is we can have two hash maps. Okay, we can have two hash map, let's say hm1 and hm2, then we can store the frequency of all the elements in both the arrays and then we can make a compare, right? So we can easily find it. That is one way. But here drawback is we are taking 2 n space, right? N here and n here. Now we can do one more thing. We can do with the help of one array on one hash map only. Let's say we are taking the count of one hash map, the count of one array in one hash map only, and then when we are traversing to the other array, we can removing the elements whoever is coming here in the already occurred. So if finally if its size becomes 0, then this will also lead to a solution. Okay, but these are not the faster way, and also we are taking extra space O of n. Okay, so we will do this thing. What if we sort both of them? Let's say target TGT and the array ARR. So if we sort both of them, and then we can compare, right? After sorting, both of them should look equal. If it doesn't look equal, that means it is a violation and it will never be equal. So what we will do, if we sort both of them, and then we will compare the elements. But now here also you can have a issue that sorting takes n log n, right? So why to do on n log n if we can solve it with the O of n? So yeah, so we have a sorting called counting sort, right? So counting sort basically takes O of n only. Now you might have a question that why don't we use counting sort everywhere if it is O of n? So there is a reason. Actually counting sort is good only when the numbers in a array are not in a very huge range. Okay, see here the numbers are only 1000 up to 1000 numbers, right? So it's a smaller range. So if whenever you are seeing anywhere a smaller range, you should always choose counting sort if it is required. If sorting is required at all, you should always go for counting sort. Now those guys who don't know about counting sort, I have put the link of the counting sort video in the description box, so you can follow that. So let me tell how we will solve it using counting sort. So first of all, what we will do, we will sort them with the help of counting, and then we would be checking both of them. So I have all the two solutions. Let me show you both of my solutions which I have basically already submitted. So let's check first of all the one which having the single hash map. I didn't solve with two hash map because then it would be extra space. So see here I have created one hash map where I will count the frequency of one of the array. See here I am calculating the count of frequencies of all the values. Now see here I am traversing over the second array which is target, right? Now what I am doing here is I am checking in hash map whether this value is there or not. If let's say this value is there, if let's say this value is not there, then immediately we should return false, right? Otherwise what I am doing here, see here, if it is there and its frequency is greater than 0, then I am decreasing it by 1, okay, because this y occurred already here. Otherwise if it is not the case, then what I am doing here, I am checking if it contains and its frequency equal to 0. That means we have to remove it from the hash map. So in this way finally we will check if both of them are equal, then hash map size would become 0. Okay, so this is with the help of single hash map, but if I run it, its time complexity is not that good and also it's taking extra space. Then I solved it with the help of counting sort. Okay, so don't worry, I will do a dry run of this code. So this is my counting sort. So what happens in counting sort? See here, this is my counting sort code. So let's explain with the diagram. So suppose we want to sort this array using counting sort. So first step what we have to do is, we have to find the maximum value in this array. So 5 is the maximum in this array. Okay, so it is 5. Now what we have to do, we have to create another array of size 5 plus 1, this max value plus 1. Okay, so what we will do here, we will create another array like this, and this would be of size 6 because 5 is the max here. Okay, so we will create an array of size 6. Okay, so I have created this array of size 6. Now see, we will traverse through this array. So this, see here, this is very first, it is 4, right? So we will go to 4 index and increase it by 1. So 0 plus 1, it will 4. Now we are at here 2. So go to 2, and 2 plus, this is already 0, so 2 plus 1 plus 0. So it will become by 1. We will increase by 1 basically. It is 3, so go to 3 index, increase by 1. So this also will become 1. Come to 3. This is again 3, so we have to increase this guy by 1. So now this will become 2. Now come to here. This is 5. So 5 coming first time, so we have to increase it by 1. So this will become 1. Now come to 4. So go to 4 index. At 4 it is 1, so we have to increase it by 1. Okay, so these are the frequencies of all the elements. Okay, now what we will do, we will make a resultant array. I will use this array itself, the original array. So let's say I am bringing it back here. So see here, now we will traverse through this array. So go to very first location. This is 0. So 0 came 0 times, right? So we don't have to do anything. Now come to this location. 1 came 0 times, so we don't have to do anything. Now come to here. So 2 came 1 time, so we have to put 2 here only 1 time because it came 1 time. Now come here. So it tells 3 came 2 times, so we have to put 3 here 2 times. 3 and 3. Now come to here. It says 4 came 2 times. These are the frequency, right? So 4 came 2 times. So we have to put 4 and 4 2 times. Now come to here. 5 came 1 time, so we will put 5 here. Now you can say this is our sorted array. Okay, and this also happen in O of n. So this is called a count sorting. Okay, this is very important, but use it whenever you see that range of numbers is not very big. So what we will do, we will use this methodology, and then we will keep on checking both the arrays. If they are equal, then we will return true, otherwise false. So then now I will show you my code. See here, first of all, I am just creating getting the max value in my this array. This is the counting sort thing. Then I am creating one counting array of size max plus 1. Okay, then see here, I am getting the frequency of all the elements which came in the A to count. Okay, then see here, I am traversing through count variable and I am taking the frequency, and see here, while frequency, so frequency times I am putting those values, those index I value into the original array. Okay, so this is our thing. Now see here, what I am doing, we are taking these two variable, right, target and array. So what we are doing, first of all, I am checking whether the length of both of them are same or not. If they are not equal, then we will return immediately false, otherwise we will check. So see here, first of all, what I am doing, I am sorting both of them, and then see here, I am checking to the all elements. See here, I am traversing through. If at any place array of I is not equal to target I, then we are returning false, otherwise after coming out of this loop we are returning true. Okay, so let me execute the code. I am executing this code. Yeah, so let me submit it. So yeah, this is 90% faster. So guys, you can try with the hash map as well. I haven't written that code, otherwise video would be very lengthy. So thank you for watching the video, and if you have any concern, please make a comment over there.